So properties of circles. Okay. So here are the learning objectives. Take some time to read them. Read all of them. Okay. Okay. So there are many different portions of a circle. Okay. So all of them are really just going to be given in here. Okay. All these circles, all of these things are illustrated in the diagram over here. Okay. So first of center, okay, then you have the radius. Okay. So this should be familiar. Okay. What's a chord? Okay, a chord is gonna be this. Chord is this guy. Okay, arc is this, and segment is this. Okay. Um and a tangent is a point that touches a circle at exactly one point. So tangent is here. Okay. And tangent is always going to be perpendicular to your diameter. Okay, or your radius. That's one property that we should know as well. Okay. Yeah. Okay, the last one is sector. Sector is basically like it's like a piece of a pie. Okay. Like that. This is the sector. Okay. So here are the properties of circle that you should be aware of. Okay. First one, angle at center. Okay. Angle subtended by arc at the center is twice the angle subtended at any point on the remaining circumference. Okay. So if you look at angle AOB and APB, okay, basically the angle with the O in the middle is going to be the angle at center. So the angle at center will be twice the angle at the circumference. Okay, the angle of circumference is APB, is x. So if APB equals to x, then AOB is 2x. Okay, so the next one, okay, angle in a semicircle. Okay, angle in a semicircle will be equal to 90 degrees. Okay, so semicircle means okay, the hypotenuse, okay, you know the hypotenuse is the longest hypotenuse is the diameter. If the hypotenuse is the diameter, then this angle here must be 90 degrees. Okay. So this one is very easy to spot. Okay. You should pay attention to these patterns and you can spot it very easily. Okay. Then this one, okay, last another one, right? Angles in the same segment. Okay. So angles subtended by the same arc on top of the same segment. Okay. So the segment, right? So recall what a segment is. Segment is like okay. So if you can draw a segment like this. Okay. So these two angles are the same segment, so they are equal. Okay. Any questions about this tree so far? Okay. So let's say a simple example. Okay. In the diagram, O is the center of the circle and AOB is 148 degrees. Find angle ACB. Okay. So AOB is 148 degrees. Okay. And ACB, we're going to find this. So we can easily spot this as an angle at center situation. Okay. Angle at center equals to 2 times angle at circumference. So angle at circumference is going to be half of 148, which is 74 degrees. Okay. Then next example, PQ is the diameter of the circle with circle, R is the point of the circle. Angle QPR is 34 degrees. Find PQR and ROQ. Okay, so the first one, we do easily spot that this is the angle in a semicircle situation. Okay, angle in a semicircle situation. Okay, so this angle here will be 90 degrees. Okay, by angle in a semicircle. Okay, so first we find what PQR is. Okay, so we have this length, we have this angle, this angle, then PQR is this last one. So we know angles in a triangle sum to 180 degrees. Right, so this angle here is 180 minus 90 minus 34, 56 degrees. Okay. Then next ROQ is this guy. Okay. So we want to find this guy now. Okay, and we know this angle actually. So actually you can spot this as an angle at the center situation. Okay. Angle at center is going to be 2 times angle at circumference. Okay, so angle at circumference is 56 degrees. So angle at center is 2 times of 56 degrees, which is 112 degrees. Okay, and any questions about this? Okay, if not, I can try the next example. Okay, 1.2 by 1. Okay, the picture is on this paper. give you all about 3 minutes for this.
Good morning.
Okay, in the picture, the 124 degrees seems a bit weird, but let's pretend it's accurate. Alright, 1 minute. Okay, so for this question, right? Okay, the 124 definitely looks a bit off. Okay, I'll change that. Okay, so you have to find angle PRQ. The angle PRQ is here. Okay, so you notice actually POQ and PRQ, right? So actually, angle PRQ is the angle at circumference, and angle at center, is twice the angle at angle at center is twice the angle at circumference, so it's actually just half, 32 degrees. Okay, so I have marked 32 degrees. Then next, find angle PSQ. Okay, angle PSQ. Actually, no. I think this should be the 124 degrees. Okay, not this angle. Okay, yeah, error. That okay, make sure you change that. So, find angle PSQ. So PSQ is here. PSQ, this angle here. Okay, so angle PSQ. You can use angle in the same segment. Okay, same segment. So this must be 62 degrees as well. Okay, angles in the same segment. And then lastly, reflex angle QOQ. Okay, reflex angle means okay, this is 124 degrees. Reflex angle means an angle larger than 180 degrees. So it will be 360 minus 124 degrees. Angles at the point. Okay, so 236 degrees is the answer. Okay. Okay. Okay, this one I think is a pretty simple example. Okay, about 3 minutes ago for this one. Okay, can quite easily see which property to use. Sometimes the property not very easy to see. This one is pretty easy. Okay, and go to this one. Um, okay, so the simple one. Okay, angle ACB. Okay, angle ACB is here, which is of course this is going to be 90 degrees because angle in a semicircle. Okay, so angle this one is 90 degrees. Okay, angle in a semicircle. Okay, the angle CBA. Okay, then you just consider this triangle. Okay, so angle CBA is this guy. It's going to be 180 degrees minus 90 minus 27. Okay, 63 degrees. Okay, so this is 63 degrees. Okay, then the other one is also very similar. Okay, angle ADB is going to be 90 degrees as well because the angle in a semicircle. Okay, then lastly, angle DAB. Angle DAB is going to be 180 degrees minus 38 minus 90, okay, which is going to be 52 degrees. Okay, so angle in the semicircle, I think is one of the easiest property to spot. Okay, once you see a triangle with the diameter being the hypotenuse, then yeah, it's definitely you can definitely use this already. Okay, uh, yeah, I think we take 5 minute break, then we can move to circuit quadrilaterals after this. We can continue at 4. Okay, let's continue. Okay, so now we introduce the second last property. Okay, we learn two more properties after this. Okay, the first one being cyclic quadrilateral. Okay, so the main thing we have to understand here is that the opposite angles in the cyclic quadrilateral are supplementary. So supplementary meaning that the angles will sum to 180 degrees. Okay, so opposite angles. Okay, so cyclic quadrilateral, what it means the vertices lie on a circle. Okay, so this one lies, this one lies, this one lies, this one lies. So it's a cyclic quadrilateral. And the sum of the two angles that opposite will add 180 degrees. Sum of these two will add 180 degrees as well. Okay. So this is all you need to know. Okay, the part B can be this one can be derived from part A. So yeah, I don't really expect you to know that. Okay. So a very easy example. Okay. ABCD is a cyclic quadrilateral. DAB is 82 degrees and ABC is 107 degrees. Find BCD and CDA. Okay, so BCD is this guy. Okay. Then obviously we can use the cyclic quadrilateral. This guy 82 degrees plus this guy must be 180 degrees. So angle BCD is simply 180 degrees minus 82 degrees, which is 98 degrees. Okay. Then we ask also to find angle CDA. CDA is this one. Okay. Sorry, this one. So angle CDA 107 plus CDA must be equal to 180 degrees. So 180 degrees minus 107 is equal to angle CDA, which is 73 degrees. Okay. And we also see another example here. Okay. Of this cyclic quadrilateral, then these are opposite sides. The opposite sides of the cyclic quadrilateral. So they must add up to 180 degrees. So if we have 6x minus 5 plus 4x plus 15, these two will sum up to 180. Okay, so you add the two terms together and you solve the algebraic equation, you will see x is 17. Okay, then just to verify whether your answer is correct, okay, you sub x to the 17 into here, you get 97, and you sub into here, you get 83. Okay, then check, does 83 plus 97 equals to 180 degrees? Okay, it does, right? Okay, so that means you're correct. Okay, any questions? Okay, so we can try this one, I think about 3 to 4 minutes as well. Okay, so for this question, find angle ADC. Okay, so here is ADC. Okay, so we're only given info about AOC. Okay, so AOC, ADC. Okay, you can see that this is an angle at the center. Okay, angle at center is two times the angle at circumference. So the angle at circumference is half of this angle at center, which is 110 degrees. So the answer is 55 degrees. Half times 110 degrees. Okay. Then once we have this everything, it's quite easy to see. Okay, you want to find angle ABC. Okay. So these are opposite angles. It's actually a cyclic quadrilateral. Right. This and this are opposite angles. So angle ABC will just be 180 minus 55, which is 125 degrees. Okay. So we're using angle at the center and then angle in the cyclic quadrilateral being complementary. Okay. Then the last one we might have time to go through, so let's get it. Okay. Now, of course, the example, the other examples that I didn't manage to go through, you can go ahead and give it a try at home as well. Okay. Okay, this is the last property that we'll be learning for this chapter. Okay, tangent perpendicular to radius. Okay, so the tangent is perpendicular to the radius at the point of contact. So if you have a point, okay, a point outside here, okay, you draw a point, you draw a line such that it touches the circle exactly once. So this point P, if I were to draw a point or a line right, such that it touches the circle, this is called tangent. Okay, it touches the circle exactly once. Okay, so these two are tangents. Okay, and of course OA and OB are the radii of the circle. Both are radiuses, right? Okay, radii of the circle. Okay, so if you were to draw the radii and then the tangent, you'll see that actually these are perpendicular to each other. Okay, and not only that, besides the fact that they are perpendicular, the tangents are also equal in length. Okay, they will be equal in length. Okay, the part C don't really care, they are not important. Okay, but tangent will be perpendicular to the radius, and then the tangents will be equal in length. Okay, so we see some quick examples. Okay, this one is not really anything to do with properties. Okay, essentially just Pythagoras theorem. Right? So here's 8, this is 17. So here will be 15. Okay, using Pythagoras theorem. 17 squared minus 8 squared. Okay. The other example, this one I will skip it because it's not too relevant. Okay. Okay. Yeah. So last example of the chapter. Okay. 1.2.5. Okay. Give this question a try. About 3 to 4 minutes. So 1.2.5. Tangent from external point. 30 more seconds. Okay, so for part A, okay, write down the length PB. Okay, you're given some info here. It's in diagram A. Write down the length PB, given a reason. Okay, so actually you can't really do that straight away, but length PB will be equal to PA. Okay, because of the equal tangent theorem. Okay. And the next part is to find PA. Okay, so if you find PA, you can find PB. Okay, so you answer the question. So you are also given that OP is 6 cm. Okay? OP is 6 cm. Oh, sorry, 10 cm, and OA is 6 cm. Okay. So to find AP, which is the same as PB as well, okay, this is a right angle triangle. So you can use Pythagoras theorem. Right? It's just going to be square root of 10 squared minus 6 squared, which is square root 36, which is 6 cm. Oh, I'm sorry. 10 squared minus 6 squared, okay, 64. Okay, square root of 64 is 8 cm. Okay. Yeah, so that means angle PB, sorry, length PB will actually be 8 cm. Okay. Then next, okay, find angle AOP. Okay, AOP is this over here, AOP. Okay. So this one actually is, since it's a right angle triangle also, right? What you can do is to take a trigo ratio. Okay. So this angle here is angle AOP. Okay. So what lengths do we know relative to this length, to this angle? First angle, we know the adjacent, we know the hypotenuse. Right? Adjacent is 6 cm and hypotenuse is 10. So we use cosine, okay, tokaso. So cosine of angle AOP is equal to adjacent, which is 6, hypotenuse is 10. Okay. Then angle AOP is simply just going to be cosine inverse of 6 over 10 to 3 over 5. Okay. Which is 53.1 degrees. Alright, any questions for this? Alright, then yeah, so here we did use some Pythagoras theorem trigonometry concept. Okay, hopefully you all still it's a subsequent chapter that we're going to go through later today. Okay, but of course I think you all should have some kind of knowledge of that. That's why it is used a bit in this chapter. Okay, the last example, okay, the alternate segment theorem is not on the server. Let's ignore it. Okay. Yeah, so here a quick overview of what we went through, right? The 5 main properties. Okay, so the first one, angle at center is 2 times angle at circumference. Second one is angle in the semicircle is 90 degrees. The third one is angle in the same segment are equal. Yeah, angles in the same segment are equal. Fourth one is angles in a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral are supplementary, meaning they add up to 180 degrees. And lastly, we learned that the tangent is perpendicular to the radius, and then the tangents are actually going to be equal in length from the same point. Okay, and also you see how to use Pythagoras theorem and trigonometry to find certain lengths if we are given that situation. Okay, any questions on this? Okay, if not, we move to what we were discussing about. Okay, so this chapter, okay, I think is the Pythagoras theorem part. I think most people should understand. The trigo maybe is a bit harder. Okay, so we learn how to apply Pythagoras theorem to find unknown sides in right angle triangles. Use trigo ratios to find angles and sides. Solve real world problems involving angles of elevation and depression. Apply sine and cosine rule, and then calculate the area of a triangle using half AB sine C. Okay, so I guess another possible point of confusion in this chapter as well is the when and how to use the sine rule and cosine rule. Okay, so here, okay, Pythagoras theorem. So this one should be quite familiar with it anyway. So in a right angle triangle, the square of the hypotenuse, okay, hypotenuse is the longer side, okay, is the sum of the square of the 2 other sides. Okay, so the 2 other sides, the horizontal and vertical A and B, right? You square them, add them up together, you will be equal to the square of the hypotenuse. Okay, so this one is a pretty should be a pretty familiar concept to you guys. Okay, and how to use it? Okay, it's not difficult. Okay, rectangle ABCD with AB is 9 cm and BC is 12 cm. It's labeled as picture. Find the length of diagonal AC. Okay, this guy. So that's pretty simple. AC squared, okay, by the Pythagoras theorem. Pythagoras theorem. Okay, AC squared equals to AB squared plus BC squared, which is equals to AB is 9 and BC is 12. Okay, then AC is simply has to be square root of 81 plus 144. Okay, which is 225. Okay, which is square root of that is 15. Okay, and of course you can not only find the hypotenuse, you can go and find other sides as well. Okay, all you need to do for Pythagoras theorem to work, right, is you need two sides. Okay, one of the side hypotenuse, both sides. Okay, whatever it is. If you have two sides, you can always find the last side if you have a right angle triangle. Okay. So here, okay, we have a right angle triangle, then we have an unknown side x. Okay. We have an unknown side x. But then by Pythagoras theorem, we know that x squared plus 8 squared equals to 17 squared. Okay. So then you solve the equation. So 17 squared is x squared plus 8 squared, which means that x is 15. Okay. One consideration that you might have noticed as well is usually when you have x squared equals to 225, if you take x, right, it will be plus minus 15, plus minus 225. Okay. But because we are considering length, right, a length obviously cannot be negative. Okay. A length cannot be negative. So yeah, here we just reject the negative answer. So only take the positive one. Okay. Very simple question. Maybe this is maybe the 2 minutes to solve. Very simple. Okay, when you look at this, okay, um, so here you can easily apply Pythagoras theorem. It's a right angle triangle, right? Then you have two sides, the hypotenuse and the edge. Okay. So by Pythagoras theorem, okay, you have 3 squared plus h squared equals to 5 squared. Okay, so 9 plus h squared equals to 25. Okay, minus 9 on both sides. H squared is 16. Okay, then you square root it. It will be plus minus 4, but like you can just reject the minus. So h is 4 cm. Okay. Then this one, very simple example, so about 2 minutes. Okay. This one also very simple, right? Apply Pythagoras theorem again. BC squared. BC squared plus 7 squared equals 25 squared. So BC is actually square root of 25 squared minus 7 squared, which is square root of 576. Okay, BC is 24. Alright. So BC is 24. Then perimeter of triangle ABC. Perimeter is just add them up. 7 plus 25 plus 24. Okay, 56 here. Okay, nothing too difficult. Pythagoras theorem, okay, very easy to see. Two right angle triangle and you have two sides given, you can definitely use the Pythagoras theorem. Okay. However, when you go to things like sine rule, cosine rule, then maybe it's not super easy to know when to use, but okay. So now, okay, we move on to trigo ratio. Well, trigo ratio also works for right angle triangles. Okay. So the way to memorize is Tokato. Okay. I'm sure you heard Tokato before. So tangent is opposite over adjacent. Sine is cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. Okay. So if you have your angle theta over here, then adjacent is of course next to it. Opposite is the side furthest away from it, and hypotenuse is always the longer side. Okay. So we yeah, of course we use Tokaso to memorize it. Okay. Tokaso. The first letter is the starting letter of the trigo function. So TOA is TOA, so T is tangent, okay. Then so is, for example, is sine, then opposite SOH, opposite of hypotenuse. Okay. So when to decide which of these three things to use, right? Sine, cosine, tangent, to decide which one to use, what you should do is to really look at your angle. Okay, you find your angle first. Then you look at what sides you have that are given. Okay. So for this example over here, your angle here is theta. Okay. What sides are you given? You are given with respect to theta, right? This is adjacent. Okay. And with respect to theta, this is hypotenuse. Okay. So you have adjacent, you have hypotenuse. So you should use car. Okay. Because cosine is adjacent over hypotenuse. So cosine theta is adjacent 5 over 8. Okay. Then if you want to find the angle, you use the inverse cosine of theta, which is you get 51.3 degrees. Okay. So this is fairly common, and you'll be doing this quite a lot. Okay. Your angle is unknown. You have two sides. You have to decide which trigo ratio to use. Okay. Sine, cosine, tangent. Use Stochastic to decide. And then calculate. Okay. So next, okay, in a triangle ABC, the right angle is at B. Okay, then you're given 40 degrees, and then you're given a side length. Find the length of BC. Okay. So in this case, what we know, right, is actually we know the angle this time, but what we don't know is the side. Okay. So based on this angle, we know adjacent. We want to find the opposite. Okay. Opposite adjacent. So opposite adjacent we should use tangent. So tangent of 40 degrees equals to opposite, which is BC, over adjacent, which is 8. Okay. So BC will be 8 times of tangent 40 degrees. Okay. In other words, it's 6.71 degrees or cm. Okay. Any questions on this? Okay. This is very important. Okay. Um. Okay. And try this next question. The 2.2.3. Okay. Everything is illustrated in the diagram. This one. Okay. Think we look at this one. Alright. So part A, find the length of xy. Okay. So remember Pythagoras theorem, you use it when you have length of two sides and then you want to find the length of the last one. Okay. So here you want to use Pythagoras theorem. So 13 squared equals to 5 squared plus xy squared. Okay. So 13 squared equals to 5 squared plus xy squared. Okay, which means xy squared equals to 13 squared minus 5 squared, which is 169 minus 25. Okay, 144. And if you square root it using a calculator, then xy just 12 cm. Okay. Then part B, find the value of xzy, giving your answer in degrees correct to 1 dp. So xzy is this fellow. Okay. So with respect to this angle here, what lengths do we know? We know adjacent, we know hypotenuse. So you should use cosine. Okay, cosine of angle xzy equals to adjacent over hypotenuse. Okay, so xzy is just the inverse cosine of this. Okay, of course, if you want, right, you can use sine also. Okay, you can use sine because earlier we found that this is 12, right? 12 cm. Okay, if you want, you can use sine also. But I wouldn't recommend using sine because imagine you calculated this wrongly. If you calculate this wrongly, then your answer will be wrong. So I recommend using cosine because cosine uses the two values that are given in the question. Okay. If you use the values given in the question, then you are less likely to make mistakes. Okay. Yeah, the one. No time for that. Okay. So now we look at angle of elevation, angle of depression. Okay. So angle of elevation and depression. Okay. It's simply given in this picture over here. Like how it very works. Okay. So angle of elevation is if you look at from an observer to an object on top, right? angle of elevation is just going to be this from the vertical from the horizontal. Okay, and angle of depression is from the horizontal on top. Then you look down. What it's going to be? Okay. So actually, notice that these two angles will actually be the same, right? In this sense, okay. Why would they be the same? Is because of alternate angles. Because obviously these two lines are parallel because they are horizontal lines. They'll be parallel. Okay. Okay. So then this example is simply just going to be an application of trigo. Okay. In the terms of angle of elevation. Okay. So a boy stands 40 meters from the base of the building, meaning this is 40. Then he observes the top of the building at an angle of elevation of 38 degrees. Okay. So that means this is 38 degrees. Find the height of the building. Okay. So you can construct a right angle triangle. Okay. So we can find out what this h is. Okay. So for this question, once again, how do we identify which sides to use? Okay. 38 degrees, right? We have adjacent, we have opposite. Or we want to find opposite. Okay. So adjacent, opposite. So we choose tangent. So tangent of 38 degrees equals to opposite with h over 40, which means that h is 40 times tangent 38 degrees, 31.2 degrees. Okay. Any questions? Okay. So right from this point onwards, I think I think you should be able to understand quite clearly what which trigo ratio to use. I don't think I'll spend too much time discussing which trigo ratio to use. Okay. Okay, now we're talking about angle of depression. Okay. So lighthouse keeper at the top of a 60-meter lighthouse. Okay, so here sees a boat at an angle of depression of 20 degrees. Okay, so this is 20 degrees. Find the horizontal distance from the boat to the base of the lighthouse. So the boat is here, the base of the lighthouse is here. So we want to find D. Okay. So one thing to note, okay, because of alternate angles, right, we can consider this is going to be 20 degrees as well because of alternate angles. Okay. Alternate angles, remember, is the Z shape thing. It's a Z shape. So this will be 20 degrees. Okay. Then 20 degrees, you know opposite, you want to find adjacent, so use tangent. So tangent 20 degrees equals to 60 divided by D. Then if you make D the subject, you get 165 meters. Okay. Okay, then now we have to try this one. Give maybe about 2 to 3 minutes for this. Thirty more seconds. All right. So I'll go here. Okay, all this nonsense. Right. The goal is to find theta. Okay. So to find theta, okay, we require okay, we require two sides of this triangle. Okay. So we should consider this triangle and try and find two sides of it. Okay. So it should be quite obvious. One of them is very obvious. Okay, this is going to be 25 meters. Okay. Because it's a rectangle, right? The bottom one is a rectangle. Okay. Then now we want to find this length here. Okay, this length here also not difficult to find. It's just going to be 30 minus 12, right? So it's 18 meters. 30 minus 12 is 18. So now we look at this triangle. Okay, then we look at theta. Okay, theta, you have opposite, you have adjacent, so you should use tangent. So tangent of theta will be opposite, which is 18, and adjacent is 25. Okay, so theta is tangent inverse of 18 over 25, which is equal to 35.8 degrees. Alright. This one no time also. Okay, now we talk about sine rule and cosine rule. Okay, so these two are rules that is given in the formula sheet, so you don't need to memorize it. But what you should know how to do is how to use it. Okay. So for the sine rule, for any triangle ABC with sides A, B, and C opposite to angles A, B, and capital A, B, and C respectively, then A over sine A equal to B over sine B, C over sine C. Okay. So okay, typically when you will use this is when you know two sides and so-called non-equivalent angle. Okay, so okay, what this even looks like, right? If this is A, B, C. Okay, then this is angle B, this is angle A, this is angle C. Okay, so these are the like a little diagram you can draw to help visualize what it is. Okay. So we will see an example of when it can be applied. Okay, then next we look at the cosine rule. Okay. The cosine rule given in your formula sheet is a squared equals to b squared plus c squared minus 2bc cosine of big A. Okay. So this is when you know two sides and then the included angle. So two sides, you know this side, and then you know an angle here, and then you want to find the last side. Okay. Then this is when you use the cosine rule. Okay. Sine rule is not so straightforward when you should use it. Okay. But in general, if you have a question that you cannot use cosine rule, then you use sine rule. Okay. Okay. Yeah. And when to use, even consider using these two. Okay. Is when you don't have a right angle triangle. Okay. So right angle triangle, you probably want to use Pythagoras theorem or the trigo ratios. Okay. Okay. So an example here. Okay. Everything is really given here. Okay. Then you ask to find BC. Okay. You have to find BC. Okay. So based on the notation of this sine rule, right? Okay. Okay. First of all, what we can find is going to be this 65 degrees. Okay. Based on the notation of sine rule, it means okay small a over sine of big A, right? So that means okay the small a, okay, if this is okay, how do I say it? Okay, maybe we look at C first. Okay, the letter C. Okay. So this is the capital C. Okay, capital C, 65 degrees. And the small c, right, will be the length that's opposite it, so 10 cm. Okay. Then for capital A is 45 degrees. Then the length small a actually will be the length opposite it, which is going to be, in this case, what we want to find, BC. Okay, so here we want to use sine rule. Okay, we want to use the sine rule. So A over sine A, okay, this is BC over sine 45 degrees equals to 10 over sine 65 degrees. Okay. And if we solve it, BC will be 7.0 cm. Okay. And when to use cosine rule? Okay, cosine rule is when you have two sides and then the angle you want is between them. Okay. Either that or you want to find the angle and you have all three sides. Okay. So I repeat myself, there are two circumstances. One of them is you have two sides, an angle here, and then what you want to find is this guy, the side opposite it. Either that or you have all three sides and then you want to find the angle. Okay. So those two are the common situations. So here we use cosine rule. Okay. 7 squared equals to 8 squared plus 11 squared minus 2 times 8 times 11 times cosine of angle Q. Okay. Then you want to find Q, right? So you have to make cosine Q the subject, then you solve for Q. Okay. Yep. So that's about it. Okay. Give this question a try. About 3 minutes for this. So like I started already say use sine rule. So yeah, you will know what to use. Wait 20 more seconds. So as mentioned, right, you won't really in the exam, no one really tell you to use sine rule or cosine rule. So when you see a diagram, right, you should identify what you know and what you don't know, and consequently which method you should use. Okay. So you should be able to immediately identify, okay, do I use sine rule, do I use cosine rule, or do I use Pythagoras theorem, do I use trigo ratios? Okay. Look at the question for a bit and you should be able to tell. Okay. So here, okay, I already give the hint, the question title it says use sine rule. So yeah, of course you use sine rule. Okay. So let's see, okay, um find angle ABC. Okay, angle ABC of course is very easy to find, right? It's just going to be 180 minus the other two angles. So it's 180 minus 52 minus 35. So it's 93 degrees. Okay. Then let's find the length AB. Okay, length AB means this side here. Okay, so this side here. So we can use sine rule here. Okay, sine rule. What you must have, right, is a side. Okay, a side. Okay, so the side we know is 12. Okay, and we must know the angle opposite the side. Okay, it's 35. So it says A over sine capital A equals to B over sine capital B equals to C over sine capital C. Okay, so let's consider maybe this as my A and then this is my sine of capital A. Okay, so 12 over sine 35 degrees equals to, okay, what do we want to find? We want to, in the end, we want to find AB. Okay, AB is this guy. Okay, and the angle opposite is 52 degrees. So it's AB over sine 52 degrees. Okay, so in other words, AB is sine 52 degrees times 12 over sine 35 degrees. The answer is 16.5 cm. Okay, then for this one, you can give it a try how to apply the cosine rule. Okay. Maybe about 2 to 3 minutes more. Okay. It's very important to know how to use sine cosine rule and when to use it. Okay. So I try my best to mention the circumstances in which you have to use either Okay. So cosine rule, once again, I repeat myself. When to use it is you know two sides and then you know the angle between the two sides. Okay, the equivalent, so-called equivalent angle. And you want to find the opposite side of the angle. Okay, that's number one. Number two is when you know all three sides and you want to find the angle, any angle inside. Okay, so the equation for cosine rule is given will be given in the formula in the front, right? So it's going to be a squared equals to b squared plus c squared minus 2bc cosine A, capital A. Okay. So in this context, okay, we want to find xz, right? Okay, xz is your small a, and then capital A is the length opposite small a, which is 63 degrees. Okay. So this means that xz squared equals to okay b squared. Okay, b for b let's let it be 9. Okay, xy is 9 and yz be 14. Okay, so 9 squared plus 14 squared minus 2 times 9 times 14. And as mentioned, right, the capital A here is 63 degrees. Okay, it's the angle that's opposite the length that you want to find. Okay, so xz will just be square root of this whole thing. Okay. So the whole thing inside is 162.6 cm. Or not cm, 162.6. Then if you square root it, it will be 12.8 cm. Okay, any questions about sine rule, cosine rule? Okay. Then lastly, area of a triangle. Okay, this one very simple although it's the same notation. Right? Half AB sine of capital C. Okay. So if you know two of the sides and then you know the sine of the side that is opposite, okay, you will know how to find the area of any triangle. It doesn't have to be right angle. Okay. So in this question over here, okay, you're going to use this trigo identity. Okay. PQR is given like this. Okay. And if you want to find the area of this triangle, then you use half A, B, uh, and sine C. Okay. Okay, this should be, sorry, this is wrong, this is 348. Okay. This should be the angle here. It's not wrong. Okay. Answer is 46.8 cm squared. Okay. Then now, okay, you're given another question. Okay. The lengths are the area, the angles are given. Okay. So how do we find the area of this? Okay. So to find the area of this, right? Okay. What do we need to find first is we need to find two sides, and then we need to find an angle between the two sides. Okay. So for this guy, we actually don't have that yet. Okay. So that means we either have to find this side or this side. Okay. And we can easily find this side using the sine rule. Okay. This side here can be found using the sine rule because we can calculate this angle as well. This is going to be 70 degrees. Okay, if we use this, okay, 12 and 70. So 12 over sine 70 degrees. Okay, it will be BC over sine 40 degrees. Okay, if you want to find BC. Okay, so this allows us to find BC. Okay, if we find BC already, then what we can do is to use half the area of triangle. So area equals to half times BC times AB times sine 70 degrees. Okay, because 70 is here, and then AB and BC are the two angles that are to its left, that would surround it, the two lengths that surround it. Okay, so that's exactly what was done here. Okay, this question we will skip it. I think yeah, this one area of triangle. Area of triangle, I don't think it's too difficult to find. So I think I'll skip this portion. Okay, unless you don't need me to go through. Okay, I think area of triangle. You just have to be aware for this chapter. You'll be aware of what A, B, C mean, and then the capital A, capital B, capital C. Okay. Okay, so this is what we covered for this. Okay, Pythagoras theorem, then the three trigo ratios, angle, elevation, and depression. And then how the angle of elevation from A is angle of depression from B. And sine rule, cosine rule, when to use it and how to use it. And lastly, the area of a triangle that does not have to be right angle. Okay, then we move. Okay, this is like a pretty simple topic. Okay, I think this one most people shouldn't have too much issues with it. Okay, it's called mensuration. Okay, so mensuration. Okay, basically you want to calculate the parameter, arc length, area, sector, all that stuff, surface area, volume, and solve problems that have multiple of these things combined together. Like they give you like a water bottle, the design of it, maybe as a sphere and a cylinder, then calculate the volume, the surface area. Okay. Then lastly, convert between units of area and volume. Okay. So there are some common 2D shapes that you all should be aware of how to calculate the area. Okay, like rectangle, triangle, how to calculate. Okay, like a right triangle. Parallelogram, all this also. Okay. Trapezium also like you would know, but it's not super common, right? Half A plus B times height. Half the upper length, the low plus lower length times the height. Okay. Circle. Okay. The perimeter area. Okay. Everything else. Okay. Circle. Okay. Then the last one is a sector. Okay. Sector, recall from earlier, is essentially a circle, right? It's just like a pizza pie. It's like a portion of a circle. So how to really think of this formula, right, is, for example, if we look at the area is pi over, area is pi r square, right? That one we know. Okay. This theta over 360 degrees, basically it tells us a fraction of this whole circle, that how much of a fraction of the whole circle do we want? Okay, how much of a fraction of the whole circle do we want? This gives us the area. And then what about this? Okay, theta over 360 plus times 2 pi r plus 2r. Okay, so this one, it happens so that okay, you have this radius, right? This sector. Then of course these two are the radius, right? So that's how the 2r appears. The 2r here. Okay. Then this guy here is basically the same thing. 2 pi r is the whole circle's circumference, right? I only want a fraction of it. Okay. The fraction of it determines the fraction of it out of 360 degrees is how much of the fraction it occupies. So you must divide by 360 degrees, then you multiply by 2 pi r, which is the circumference. Okay. Yeah, a lot of this can be easily memorized or derived. Okay. So this is a sector here, okay, then the angle is 73 35 degrees. Okay, then the radius is 12. Okay, then you can simply use the formula, okay, to calculate the area and perimeter. Area is theta over 360 degrees times 2 times pi r squared. Okay, here. Then perimeter, right? Okay, we calculate arc length first. Arc length is this guy. Okay, so it's theta over 360 degrees times 2 pi r. The answer is 15.71. Okay, then the perimeter is just going to be the arc length plus the 2 radius. Okay, it forms an ice cream cone. That's 39.7 cm. Okay, then next composite figures. Composite figures is when you include more than one of these guys together. Okay, so like a semicircle and a rectangle. Okay, find the total area of the sheet. Okay, so very simple, you just add them up together. Semicircle, the area, right, is going to be pi r squared divided by 2. Right, it's half of a circle. So the diameter is 6 cm, right? So radius is 3. So pi times 3 squared is 9 pi. Okay, and divided by 2, so it's 9 over 2 pi. Okay, so 9 over 2 pi. Then the rectangle obviously is based on side. So 3 times 6, 18. So the total area you add 18 and you add 14.14. You get 32.14 cm. Yeah, can give this question a try. Okay. Yeah, feel free to refer to the formulas on the first page of the chapter if you want to find like the area of a sector or the stuff. Okay. Feel free to use any of the formulas. About a few more 3 minutes. No. Okay, for part D, right, if you're wondering what that means is this. This is the so-called minor segment. This is for part D. So actually, it gets broken down into two things, like, kind of like a semicircle looking thing. It's not really a semicircle. The other thing is a triangle. Mm. more minutes. Okay, so okay, in this question, most of the formulas you will be using the one in the cover picture. Just a note, right? So find the arc length PQ. Arc length is this guy here. Okay, so using the formula, it will be theta over 360 times 2 pi r. Okay, and the radius is 8. So theta is 120 degrees. Okay, 120 over 360 times 2 pi r. Okay. Yeah, so answer is 16.76 cm. Okay. Next, find the area of sector OPQ. So area of the sector is basically this whole area. Okay. And that's theta over 260 times pi r squared. The answer is 57.0 cm squared. Okay. Then part C, area of triangle OPQ. So this area of this triangle here. Okay. So this one you can use half AB sine C. Okay, half AB then sine of the angle that's opposite the last length. So half times 8 times 8 times sine 120 degrees, 27.7 cm squared. Okay. And lastly, find the area of the minor segment. So minor segment, as I said, is here, right? Okay. So it's just going to be area of the sector, the whole thing, minus of the area of triangle. So 67.0 minus 27.7 is 39.3. Okay, any questions? Okay, not let's take a quick 3 minute break, then come back, we'll finish the rest. Yeah, sure. Okay, so I think we'll quickly finish up on mensuration. Okay, so right now we're left with surface area and volume. Okay, so the calculation is largely similar. Okay, when you have composite shapes, it's like more than one shape, then you just add them together. Okay, I think better spend the time on later topic. Okay, not as much more. Okay. So surface area. Okay. Okay, surface area. So surface area. Okay. For cuboid. Okay, cuboid means like a shape, like a cube, but then the sides are different. Okay, each of the faces add together. Cylinder basically is like the curved surface area, which is 2 pi r, okay, the circumference times h, and then the two caps, the top and bottom. For cone, right, pi r squared will be the base, okay, then pi rl will be the so-called slanted surface, the curved surface area. Okay. And then for sphere, it will be 4 pi r squared, okay, the whole thing. Okay, so you have a hemisphere, which is half of it, and you half this one. Okay, so I think it should be quite intuitive. Right, diagrams are as follows. Okay. So radius 6 and height 10, find the total surface area. Okay. So you must add the two caps also. So 2 pi r squared plus 2 pi r h. Okay, just sub in the formula, it's quite easy. Okay. Surface area of a cone. Okay, surface area of a cone. Okay, you must add the base area, which is pi r squared, then the height, the slant surface area, right, is pi rl. So pi times 5 is the radius, and the slant height is 13 in this case. Usually you use L to denote it. Okay, so add them together is 282.6 cm squared. Okay, this one I think we won't spend much time into also. Okay, it's just a surface area of a cone plus cylinder. Okay, but take note, don't add this guy also, because this guy is like being covered by the cone. Okay, so what should happen is this guy will be the curved surface area. So pi times radius times 5. Okay, then the surface area of this cone, of this cylinder, and then only the bottom. Only the bottom. Okay. Yeah, so you add those three things up as the answer. Okay. This one I also want to talk about it. Surface area of the sphere. Okay, just 4 pi r squared. Okay. So some of these formulas will be given in your front page. So be aware of which one is given. Okay. Some of it is not given, for example. Okay. Then 3D solving is also largely the same, just apply the formula. Okay, I don't think it's so difficult. Cuboid, okay, length times width times height. Prism is, okay, for prism then, okay, it really depends. Okay, usually they'll give you the formula. Okay, this one not so straightforward. Okay, cylinder is pi r squared, circle, you calculate the circle length times h. Okay, your cone is 1/3 pi r squared h. Sphere is 4/3 pi r cubed. And the pyramid is 1/3 times base area times height. Okay, so as the note here says, volume of cone and sphere are provided in the formula sheet. The others will usually be given. Okay, but you should, if you can memorize it, then that'll be better as well. Okay. Yeah, I also mentioned if you have to do a hemisphere, which is half of a sphere, okay, then you should divide the volume by 2. Okay. So an example here, okay, very common one. This one is very common. Cylinder and a cone. Okay. Area of volume of the cone of the cylinder is pi r squared h, and volume of the cone is 1/3 pi r squared h. So the total is 4/3 pi r squared h. Okay, or 1092.7 cm cube. Okay. Then this other one. Okay, we must calculate the volume. Okay. So the cylindrical tank has radius 0.5 meters. Okay, and the height is unknown. Okay. No, sorry, the height is 2 meters. So the volume of water to fill this whole tank up fully, right, is 1.57 meters cube. Okay. And if it flows at 0.1 meter cube per minute, then you divide by 0.1, you get 15.7 minutes to fill it up. Okay. So the calculation, I don't think it's too troublesome. Okay. It's very not that bad. Okay. Volume of sphere given radius, simple also. Okay. Therefore, for part B, I guess it's a bit more complicated. Okay. For part B, what you have the sphere, right? The metal sphere. Okay. The volume is 972 pi. Okay. Now you melt it and you want to put it into a cylinder with radius 6 cm. Okay. So that means the height is unknown. We want to find the height. Okay. So the volume of the cylinder is 36 pi h. Okay. We know the radius of the cylinder, but we don't know the radius, or we don't know the height. Okay. So 36 pi h equals to 972 pi. Okay. Then if you solve it, H will be 27. Okay, so you potentially a question like this is a bit harder of this type of questions. Otherwise, most of the other stuff you just copy the formula and that's all. Okay. Another example, okay, this one I'm going to go through is same thing, right? It's a hemisphere and a cylinder. Okay, hemisphere, remember the volume, right? Instead of 4 third pi r cube, is going to be 2 third pi r cube. Okay, which is half of 4 third pi r cube. Okay. Yep, so this is what we just went through. Okay, any questions about this? Okay. So okay, then now we're left with 2 more chapters. Okay. Coordinate geometry and then vectors. Okay. So this one I think we can spend a bit more time on. Okay. Yeah, just now we started at like 3:10, so yeah, we will end at about 6:10 today. Okay. So coordinate geometry, okay, our idea, okay, the very basic concept is calculating the gradient of a straight line and then how to find the equation of a straight line with different pieces of information. Okay. So the first thing to know is really the gradient. Okay, the gradient of slope of a line is how steep it is. It's steep. Like, you understand how steep it is. It's like how much as the x increases, does a how as the x increases, how does the y change? Okay. So if your gradient passes through 2 points, okay, x1, y1 and x2, y2, then your gradient is simply change in x or change in y divided by change in x. Or in other words, it's going to be rise over run. Okay, sometimes you might hear rise over run. Rise is, can you imagine, is a change in the vertical direction, is a change in y, and your run is a change in x, the horizontal direction. Okay. So calculating gradient is the gradient usually is denoted by m. Okay. It's very important to know how to calculate a gradient given 2 points. 2 points calculate gradient. Okay, and positive gradient means as your x increase, your y increase. Negative gradient means as your x increase, your y decreases. Okay, so calculating a gradient is really quite straightforward. Okay, you have 2 points here. Um, suppose this is a x2, y2, and this is x1, y1. Okay, then you have y2 minus y1, 9 minus 3 over x2 minus x1, so 5 minus 2, so 6 over 3. The answer is 2. Okay. And for second one, similar. Okay. Make sure to use brackets. When calculating gradient, the only like caveat is you put brackets. Okay. So minus this same thing, -2, -4. Okay. Okay, no problem. Now 3, make sure you put minus or -1, then it's going to be +1. So it's -6 over 4, which is -3 over 2. Okay. Always put a bracket. Okay. Whether it be like this chapter or like algebra or all these chapters, always put brackets. Okay. Then quick practice about 3 minutes. 4.2 I calculate the gradient of these two set of points. Okay. That's simple also. Okay, you usually ask the second point as my x2. This one x1, y1, and x2, y2. Okay. So it's simply is 8 minus 2 over 4 minus 1, which is 6 over 3 is 2 for part A. Part B is going to be 1 minus 5 over 4 minus 0, which is minus 4 over 4, which is -1. Okay, very simple. Okay, so now, okay, to go, we define a straight line using the gradient, and then this thing also called the y-intercept. Okay, the y-intercept, basically, if you draw on the graph, it will be, this is going to be a y-intercept. Usually, we denote it with the letter C. Okay, the letter C will tell us the y-intercept. Okay, and M is the gradient. Okay, so there are two. Okay, the third way I would really say is too common. Yeah, I would not recommend the third way. Okay, the first two ways are gradient intercept form and then the point gradient form. Okay, uh, you can either use one or two. Doesn't really matter. Okay, but I prefer to use two. Okay, so two. What are you using actually to create an equation on the line? Two, you need the gradient. Okay, number one, you need a gradient. Number two, you need a point that lies on the line. So, for example, if I'm given that a point has gradient, has a certain gradient, and then I know that x1 y1 lies on the line, then I can find the equation of the line. Okay. Um, Alternatively, for the gradient intercept form, okay, you still need the gradient, but instead of just an arbitrary point, you need the y-intercept. Okay? If you have the y-intercept already, then perhaps you can use equation one. Is a bit easier. Okay. Otherwise, if you don't know the y-intercept, I suggest to use equation two. Okay. So okay, example, gradient 3 passing through 2, comma 5. Okay. So obviously in this case, 2, comma 5 is not the y-intercept, so you should use the point gradient form. Okay. Y minus y1, which is 5, equals to m3 x minus 2. And you make y the subject, y equals to 3x minus 1. Okay. So you write it in this form, then you can easily see, okay, the gradient is 3 and the y-intercept is minus 1. Okay. Um, then for part B, okay, passing through 1, comma 2 and 4, comma 8. Okay. So something like 1, comma 2, like these 2 points, right? You need to find the gradient first. Okay, the gradient is number one, the most important thing to find, the gradient, right? So the gradient of this is not difficult to find. It's going to be 8 minus 2 over 4 minus 1, which is 6 over 3, which is 2. Okay, the gradient is 2. Okay, then we can use the point intercept form, right? Okay, use any point, use 1, comma 2 or 4, comma 8. It doesn't really matter. Okay, you'll see the answer is actually y equals to 2x. Okay, and the graph looks like this one. Okay, okay, any questions? I think this one is pretty straightforward. So, okay. Later on, you can give this question a try. Take about 3 minutes for this. Okay, and go through this question now. Okay, so gradient minus 2 and passing through 3, comma 4. So this one you use the point intercept form. Okay, which says that y minus y1 equals to mx minus x1. So y minus 4 equals to minus 2 x minus 3. Okay, so this is the equation. The second one, we need to find the gradient first. This is 2 minus minus 1. Okay. So it's minus 6 divided by 3, which is minus 2. Okay. Then we use the point intercept formula. So y minus. Okay, I'll use this one. Okay, you can use this one also, it doesn't really matter. M is minus 2, x minus x1, x plus 1. Okay, so it's minus 2x plus 1. Alright. Okay, any questions? Okay, calculating equation online should be quite straightforward. Okay. Then we move on to the next concept. Okay, distance between 2 points. Okay. So your distance between 2 points. Okay, this unfortunately this formula you need to memorize. Okay, not really help. Okay, you need to memorize the formula. Okay. Okay, essentially it's derived using the Pythagoras theorem. Okay, but you don't need to care too much about the derivation. Okay, it's square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So this allows you to find a distance between 2 points in the Cartesian graph. Okay. So example, okay, finding a distance between A12 and B4 6. Okay. So you just let this be x1, x1, y1 and x2, y2. Okay. Simply d is going to be square root of 4 minus 1 squared plus 6 minus 2 squared. So it's square root 25, which is equal to 5. Okay. Then for second one, okay. So this one is the x1, okay, x1 3 minus, wait, sorry, no, okay, 3 minus minus 2 squared plus minus 1 minus 3 squared. Okay, square root 41. Okay, so this is what it looks like. Okay, it's an illustration. Okay, any questions about distance? Okay, calculate this, pretty simple. Okay, so this one is quite straightforward. Okay, this is the formula, right? So it's square root. Okay, for part A, it's going to be square root of D is going to be square root of 4, okay, like 4 minus 0 squared. Okay, just don't care about the 0. 4 minus 0 squared plus 3 minus 0 squared, okay, which is square root of 16 plus 9, which is square root of 25, which is 5. Okay. Then for part B, square root of 5 minus 2 squared plus 3 minus 1 squared, which is square root of 3 squared plus 2 squared, which is square root of 13. Okay, sorry, 5. Wait, oh, wait, I think I put, okay. Yeah, 5 minus 2 squared plus 3 minus 1 squared. Okay, so this is square root of 3 squared plus 4 squared, which is, as per you, it is the same, so it's actually just 5. Okay, and actually that's it for coordinate geometry. Okay, so coordinate geometry, I don't think it's that difficult, but just that the questions that can come are pretty tedious. Okay, yeah, this is like quite a simple version of what's learned in EMath. Okay, so let's remember to calculate the gradient, calculate the equation of a line using either the gradient and the y-intercept or the gradient and the point on the line. Okay, so the point gradient intercept and point gradient form, and then how to calculate distance between 2 points. Okay, so now we move on to the last chapter, okay, which is vectors in 2 dimensions. Okay, this chapter I think quite a lot of people struggle with it. So I think it's one of the more difficult chapters in my opinion. Okay, so for vectors in 2 dimensions, okay, so this one has a few different ways to represent the same info. Okay, so the first one, this x on top and y below, it looks like a fraction. Okay, it's called the column vector notation. Okay, so that's a column vector notation. Then AB is another way to represent. Like if you have a vector that goes from point A that goes to point from point A that goes to point B, then you can write it like that. Okay. Then sometimes they also use this small letter A. Okay, but this small letter A, notice is like bold, right? Okay, then to write it, you note it with a tilde. Okay, this little squiggly line below. Okay. Then if you put these vertical lines, the vertical lines, if you put it like outside, right, it means I want the length of vector AB, okay, or the length of vector A in this case. Okay. Then we should also notice how we may treat a vector as a line segment that is directed. Okay, directed meaning there is a direction. Okay, for those who take physics, you know that difference between a scalar and a vector is a scalar quantity has no direction, but vector one has directed, right? And also how to write it as a column vector. Then we work with translation vectors and position vectors. Okay, find magnitude and perform addition, subtraction, and scalar multiplication. Okay, so two vectors you cannot multiply with each other. You can only scalar you can multiply with vector. Vector you cannot multiply with another vector. Okay. And lastly, express vectors using the sum difference of two coplanar vectors. Okay, so we'll see what that means. Okay, so quick introduction, right? Okay, scalar has magnitude only. Okay, like time, mass, temperature. Okay, vector has magnitude and direction. So, like if you say, okay, I traveled for two km, then people ask you, you travel 2 km where? Okay, vector you have to say, okay, I traveled 2 km like north, for example. Okay, so there's a direction associated with your vector. Okay, it must have magnitude and direction. So okay, then now introduce these 3 ways to write it. Okay, the arrow notation, the bold notation, and then the column vector notation. Okay, and the magnitude is simply just going to be whatever these notations are. Then you put the 2 vertical lines outside. Okay, and for EMath usually we work with this one, the third one. Okay, so now we look at what a position vector is. So a position vector is simply the vector from origin. Okay, origin is 0, 0. It is a vector from the origin to P. Okay. So example, if your P here is 4, 3, okay, if your P is 4, 3, then the position vector is going to be 4, 3. Okay. So how to write a position vector? Okay, the first letter will always be O. Okay, first letter will always be O. The second letter is going to be whatever point you want to represent. Okay, then what are the terms here? You can just see the x coordinate is the term here and the y coordinate is the term here. Okay, so position vector is a vector from the origin. So it's 4, 4, 3. Okay. But of course, for vectors, right, you need not start from the origin. Okay, you can start from anywhere else. It doesn't have to be from the origin. So I can start from this point 1, 1, and I want to go to 5, 4. Okay. So what happens here is actually I'm moving 4 units in the x direction and 3 units in the y direction. Right. I'm going the x coordinate goes from 1 to 5 and then the y coordinate goes from 1 to 4. So this is 4, 3. So actually this line segment, right, AB is actually equal to 4, 3 also. Okay. But notice it did not start at the same point. Okay. So actually these vectors are the same. But you can kind of like move them around. Okay, this vector I can like move this guy around like here also. They're the same vector. Okay. So this is what I call a directed line segment. A directed line segment means there's a direction, and a line segment means you have a starting and ending point. Okay. Any questions for this? Okay. Then the most important result, okay, for any 2 points PQ, P and Q, PQ equals to OQ minus OP. Okay, so this means, okay, you see, you are writing any random vector in terms of the position vector. Okay, O of the position vector of the second letter OQ minus the position vector of the first letter, okay, OP. Okay, so second letter minus first letter. Okay, then of course you can say that PQ is minus QP. Okay, if you want to reverse the direction of the alphabets, then you can just put a minus sign. Okay, then afterwards we just simply talk about the magnitude. Okay, the magnitude is the last real concept we want to talk about. Okay, the magnitude is simply just the length. Okay, all of these vectors here have lengths. Okay, the length. So you can easily calculate the length of the vector. Okay, and the length of the vector, you can essentially just use Pythagoras theorem to calculate it. Okay? Or you can just use the formula, it's going to be square root of the top square plus bottom square. Okay, so square root x squared plus y squared. Okay, so an example here, 3 minus 4, then the size of vector v will be square root of 3 squared plus minus 4 squared, which is 5. Okay, and to find the coordinates, okay, to find vector AB, for example, okay, AB means O of the position vector of the second letter minus position vector of the first letter. Okay, so you get 5, 4. Okay, then the magnitude is simply just going to be square root of 5 squared plus 4 squared. Okay, 41, square 41. Okay. Any questions about any of the earlier stuff? Okay, then give this a try. Maybe about 3 weeks. Okay, maybe 30 more seconds. Okay. So okay, PQ in common form. So PQ actually is going to be, okay, if we use the earlier formula, it's going to be OQ minus OP. Okay, and OQ and OP is simply just going to be these coordinates written in vector form. So OQ is going to be 1 minus 2, and OP is minus 3, 5. Okay, then you can just add them together, right? So it's 1 minus or minus 3, then minus 2 minus 5. So it's 1 minus minus 3 is 1 plus 3. So it's 4 minus 7. Okay. Then mod of PQ is simply just going to be square root of 4 squared plus minus 7 squared, which is square root 65. Okay. Okay. Yep. Then next we talk about translation of vectors. I don't know why it's empty. Translation of vectors. So if I give you a vector, I give you a point 1, 2, and I say it's translated by a vector. So you can imagine this particular point 1, 2, you translate by a vector. Okay, so the x part here is 3. So that means 1, 2, it moves 3 units in the x direction. And then minus 5 means it moves 5 units in the y direction, but you actually going down because it's negative. Okay. So how to calculate it? Simply you take 1, 2 plus this vector. So it'll be 4 comma minus 3. Okay, 4 minus 3. So you can imagine, okay, 1, 1, 2, okay, then this 3 minus 5, right? Okay, so 3 means it goes 3 units in the positive x direction, rightwards, and then you're going 5 units in the negative y direction. Okay, and the new point is 4 minus 3. Okay. Any questions about this? Okay, then you can calculate 5.2.2. Very simple as well. Okay. This one I think is quite straightforward. So you simply just add the two vectors together. Okay. So the first one, right, for OP prime, the image, right? So it's OP prime will just be OP, which is 2 minus 1 plus vector V. Okay, vector V is minus 2, 4. Okay. So it's 2 minus 2 over minus 1 plus 4, which is 0, 3. Okay. And for OQ prime, it will be minus 4, 3 plus minus 2, 4. Okay. Which will be minus 6, 7. Okay. Then, yeah, those are the position vectors. Okay. Yeah, then this portion we kind of already know what to do. Okay, it's essentially a matrix, right? So you add two vectors, you add them you add the entries together, entry wise. Okay, you subtract, then you will subtract entry wise. And if you multiply by a scalar multiple, then the scalar multiple gets multiplied to the first and second, both of the terms. Okay. So if I ask you to find 2v plus u, okay, you calculate 2v first, simply multiply the entries of v by 2. Okay, then 2v you just add u, then get 10, 12. Okay. Then if I ask you to find the magnitude, remember the two vertical bars is so-called the magnitude, right? Okay. So u minus v, we can calculate that pretty easily. It's minus 8, 6. Okay. Then the magnitude of this will be square root of minus 8 squared plus 6 squared, which is square root of 100 equals to 10. Okay. Okay. Um. Okay. Then give this question a try. Okay. This one is not super easy. Okay, but okay, I'll just say that to determine whether they are parallel right, means you want to show that A equals to K times B. Okay. Whether if there is a number K that if there's a number K which would tell you that okay, if there's a number K which would exist that makes A equal to K times B, then they are parallel. Otherwise, they are not parallel. Okay. This one is not so simple. Maybe okay, maybe about 4 or 5 minutes. We can give it a try. Okay. Try and show whether this does exist or not. Okay, later I'll justify why it is so. Okay. Okay. Okay, let's finish up this question. Okay. Okay. So for this question, okay, as mentioned, right, okay, what you must do is to check whether one vector is a scalar multiple of the other. Okay, meaning that if A equals to K, if there is a K such that A equals to K times B. Okay, so K times B is minus K 2K. Okay, and if you want to compare this with A, let them be equal to each other. Okay, so that means that the top must be equal to the bottom. The top must be equal and the bottom must be equal as well. So K must be equals to, minus K must be equal to 3, which tells us that K is minus 3. And the bottom also tells us that K equals to minus 3, because 2K equals to minus 3 means K, 2K equals to minus 6 means K equals to minus 3. Okay, so thus we found a value of K which is minus 3. Okay, so A equals to minus 3B. So these two vectors are parallel. So why are they parallel? You can see on the picture over here. Okay. If they are scalar multiples of each other, then they look like that. Okay. Like A basically is like a stretch. You stretch B by 3 times, and then you go in opposite direction. Okay, because of the minus sign. The minus sign makes it go in opposite direction. Then the number tells you how long do I want it to be. How much longer do I want it to be than the original? Okay. Then okay, the last portion, all right, expressing vectors geometrically. Okay. So you're usually given two vectors, A and OA and OB, okay, and then you want to write everything in terms of A and B, okay, the two vectors that you originally have. You don't want to work with like C, D, all that stuff usually. Okay. If you're given A and B, you usually can express everything in terms of A and B. Okay. So if we consider a parallelogram, okay, OA equals to A and OB equals to B, okay, and we want to find OC in terms of A and B. So OC is here. OC is here. Okay, this vector. Okay. Notice that if it's a parallelogram, right, it means this vector BC is also equals to vector A, and this vector AC is also equals to vector C. Vector B, I mean. Okay. So this means, right, okay, the path I can take to go from OA to from O to C can be OA to from O to A and from A to C. Okay, but A to C is simply just B. So it's A plus B. Okay. And next I want to find AB in terms of A and B. Okay. AB, okay, you can just convert into OB minus OA, which is B minus A. Okay, using the formula earlier. Okay. Give this one a quick try. 2 minutes. This one is pretty simple. Okay. So this one, first of all, okay, you can just decompose it in terms of the position vectors. Okay. So in here, AC is simply just going to be OC minus OA. And OC is A plus B. A plus B minus OA, which is A. So it's simply going to be B. Okay, then BC is going to be OC minus OB. Okay, which is A plus B minus B, which is going to be A. Okay, so simple working with these position vectors. Okay. Then of course we can. Okay, sometimes vector questions is not only just this kind of calculations. You want to model a real life situation as well. Okay. Where we use a thing called displacement vector. Okay. So in this example over here, a person walks 6 meters east and then 8 meters north. Take east as the positive x direction and north as the positive y direction. So if he moves 6 meters east means it's positive 6, and then we move 8 meters north means it's positive 8 north. Okay. Represent each displacement as a vector. Okay, so east 6 meters, okay, and east is positive, so it's going to be 6, 0. Okay, you're moving in x direction, 6, 0. And north 8 meters means you are moving 8 meters in the positive y direction, so 0, 8. Okay. And then the resultant displacement vector is how much you move in total, right? You consider both movement in x and y direction. So you add these two guys together, you get 6, 8. Okay. And then the magnitude is simply just add these two vectors together. Is the x coordinate is 6, y coordinate is 8. Okay. And the magnitude is simply just the square root of the squares of the top and the bottom, the sum of the squares. Okay. And the picture will illustrate what happened. Okay. So you move 6 in the x direction and 8 in the y direction. Okay. So 5.2 is one pretty simple example as well. The last example here. 2 minutes for this. Okay, just take note of the fact that they say moves back. Okay. So moves back doesn't mean you just add it or what. Think about it. Okay. So here, the only thing to take note of is this thing called moving back. So moving back just would suggest that you don't want to add it, you want to actually subtract it. Okay. So the resultant displacement vector, okay, R will be equals to actually P minus Q instead of P plus Q. So 12 minus 5 minus 7 minus 2, so it will be 5 minus 3. Okay. And then the displacement vector is the magnitude is simply the mod of it, square root of 5 squared plus minus 3 squared, which is square root of 34 units, square root of 34 units. Yeah. Okay, so that's it for vectors. Any questions on vectors? Or any of these topics? Okay. Yeah, so this is what we went through for vectors. Okay. How to calculate a position vector from a vector from given two position vectors, how to calculate the magnitude, what is a position vector and how to calculate it. the most important formula which allows you to decompose any vector in terms of two position vectors, how to add, subtract, and scalar multiply vectors, how to check whether two vectors are parallel, okay, A equals to K times B, and then the idea which you want to express all the vectors in the diagram with relation to really the two vectors that you originally have. You don't want to have too many vectors involved in the calculation. Okay. Yeah, okay. So as per usual, okay, how it works, okay, there'll be a recording that will review it. Okay. Then there's also going to be I want to upload this solutions afterwards if you want to try some of the questions that we didn't manage to do. If you want to attempt them, I suggest giving it a try and reviewing this later. Okay. Any questions about these topics now or later? Feel free to ask as well. Okay. I like to think I covered most of the important things. Of course, some things I have to skip, of course, like, not much time. Okay. Yeah, any last questions? Okay.